Introducing OWL, a project for SCR 502 at ASU during the spring semester of 2016, created by Kanika, Caitlin, and Mina. Let's go over the basic overview of OWL. OWL stands for Another Useless Language. OWL implements delayed evaluation, and our project includes a high level and an intermediate level of our language. The file name extension for OWL is clearly.aul. And OWL was built with Antler 4.4 on both PC and Mac. We also used Eclipse and Sublime during the creation process of our project. There were 4 main steps that we went through as a team to create our language. First and foremost, we created a simple grammar using EBNF notation. We then used Antler 4.4 in the Eclipse IDE to implement a base listener class. This base listener class was generated automatically by Antler 4. We simply then extended the base listener class and wrote the translation process within that class in order to translate a high-level program to an intermediate-level version of the program. Immediately thereafter, we created our runtime using Java. Here's a snippet of the OWL grammar. As you can see, any OWL program begins at the root of this grammar. The root then proceeds to the program. The program consists of the keyword prog_start, assignment statement, a function declaration block, a main function, and concludes with the token prog_end. You can see on the bottom left of this slide that the main function consists of the token main and then a block. On the bottom right hand side of this slide, you can see that a block consists of the opening curly brace, any number of statements or expressions, and ends with a curly brace. You can also see some of the statements that we have included in our grammar. Further on in the grammar, which is not displayed on this slide, we have a rule called statement, and we list all of the various statements that are allowed as valid statements in our program. However, on this slide on the right hand side, you can see that we currently have an if statement and an else statement, as well as a while statement. You can also see on the top right hand side we have our function declaration block, which consists of any number of function declarations. OWL currently has built-in support for 2 data types, and those would be integer and Boolean. Why don't we take a look at some of the basic operations that can be performed in OWL? For example, on the left-hand side, we can see some examples of an assignment statement. Not only does this statement do assignment, but this also does declaration. In order to declare and assign, let's say, an integer x to 15, we would need to write integer with a capital I, the variable name x, the equal sign, and then the number 15. It's the exact same process to assign a Boolean, except the keyword is boo with a capital B, your Boolean name for your variable, and then the equal sign followed by the word true or false. In order to do arithmetic operations, you need to write print_num, and then within the parentheses, put the expression that you want evaluated. OWL also supports parameterized functions. On the left-hand side, you can see the high-level version of our program, and on the right-hand